Hello and welcome to another video. In this video we're going to be working on minimum time visiting all points. And on a 2D plane there are endpoints with integer coordinates, and you want to return the minimum time in seconds to visit all the points in the order given points. You can move according to these rules. In 1 second you can either move vertically 1 unit, horizontally 1 unit, or diagonally 1 unit. And you can visit the points in the same way they appear in the array. You're allowed to pass through the points that appear later in the order, but these do not count as visits. So we have some points here, and they tell us how long it takes. So from 1, 1 to 3, 4 takes 3. From 3, 4 to negative 1, 0 takes 4. So this is 7, and then here, this is 5. So what we want to do first is let's look at a graph with points, and let's actually figure out how long it takes us to visit these points. So I think what I actually want to do is get rid of this and draw another graph. So we will throw this in. There we go. And now, ideally, we want to raise this whole thing. There we go. Okay, so now we have an actual graph. Now let's just take a look at a few points. So first example, horizontal line. So let's say we have a point here and a point here. What's the distance? Like, how long would it take? This part is pretty straightforward. We can only move horizontally. So on a horizontal line, it would just take whatever that distance is, right? So if we're at, like, let's just write some coordinates, negative 5, 2, and 5, 2. This would take length 10 because the y coordinate's the same. So that one's easy. Now let's look at a vertical line. Get rid of these 2 points. So vertical line, something like this. How long does that take? And this is kind of the same thing, right? You can only go vertically, so the distance is just 4. But now let's look at an actual line, and it doesn't really matter here like which way it actually is going. It's not horizontal or vertical. It doesn't really matter the direction because we're just going to be taking absolute value. So let's just put a point over here, and let's put a point over here. So this first point, we can write down these points. This point on the top is negative 4, 4. And the second point is negative 1, negative 3. So what's the best way to do this, right? One path could just be, remember, we can't go like this. We can't draw a direct line because we have to actually visit squares that exist, right? So like we can't do this. We can't just draw a direct line. We actually every single time we either have to go down or across or diagonally. So like if we just go diagonally, let's say, we wouldn't end up at the line, right? Or if we go down and across. So one solution is go like this. You go here and then you go here, right? And so how long would this take? Like literally just going down and then going across. So to go down would take 7. So 7. And to go across would take 3. Okay, well, and that's 10. Now, is there a better way? And there is a better way. So the best way to do it is, notice that we want to get to the point as fast as we can. Now, if we go down horizontally or vertically, we move 1. Like how many total, let's look at it this way. How many total lines do we have to go? So we have to go a total of 7 plus 3, right? We have to basically make 10 moves. So we can go only horizontally or only vertically, but a diagonal movement is always going to be better. So basically our strategy should be, whenever we can go diagonally, we should go diagonally. Now this order doesn't really matter, so you can first do the horizontal or vertical, but essentially what we want to do is we want to move diagonally as much as we can. So diagonally as much as we can, then whatever is left. And so I'll explain what I mean here. So essentially we're just going to go diagonally here, diagonally again, and then diagonally again. And then if we go diagonally again, we're going to go past the point. So we don't want to go past the point. So then we just want to go whatever, like in this case, we have vertical. So we would go vertically like this. And this distance now would be 1, 2, 3, and then 1, 2, 3, 4. So we have a distance of 7, right? And that's like the optimal way to do it. Now, it doesn't really matter where you go diagonally. Like you can go like this, and then you can go diagonally here, and then this. Like these are all the same. But as long as you make 3 diagonal moves here, right? So the optimal thing is going to be to take 3 diagonal moves because diagonally gets you there faster. But you don't want to go past it. So now how do we calculate how far we can go diagonally? So that's going to be pretty straightforward. What we need to figure out is how far we need to go in the x direction and then how far we need to go in the y direction. And this is just going to be the absolute value of the differences. So in the x, it's going to be absolute value of -4 minus -1. And in the y, it's going to be the absolute value of 4 minus -3. So here we have 3, and here we have 7. And then, once we know how far we have to go in each, diagonal is just going to be the minimum of both of these. So diagonal, write that down as well, diagonal equals min of this x and y. And then when we know how far we have to go diagonally, then we know how far we have to go the rest of the way. So if we have to go 3 diagonally, right, because it's going to be the minimum here. So if we need to go 3 in the x direction, but we go 3 diagonally, we will go 3 in the x direction. And if we need to go 7 in the y direction and we go 3 diagonally, we need to go 4 more in the y direction. So we can write this down as well. So x left over is original x minus diagonal. And then y left over is original y minus diagonal. Right? So this is what we need to go. And then basically our whole result is the diagonal plus x left over plus y left over. So if we combine all this together, it's going to be diagonal plus this plus this, right? And as you can see, the diagonals cancel out, so it's really just going to be x plus y minus diagonal. And by x plus y, I mean the x difference plus the y difference minus the diagonal. So now we can try this and see if this actually works for us. So in this case, we should get 7. So let's see. So the x difference is 3. So we get 3 plus 7 minus 3. And indeed, we do get 7. So this is the equation we need to be using. We can try this for another set of points now. Oops. Well, let's just draw some other points somewhere else because not super sure how to delete this. So let's say we have a point over here. And we have a point over here. So let's get the coordinates first of all. So our left coordinate is -3, 2. And our right coordinate is 5, 5. So let's calculate our, first of all, what's going to be like our optimal path. Remember, we want to go diagonally as much as we can, and then we want to go whatever's left. So diagonal is going to be like 1, 2, 3, and then we have 1, 2, 3, 4, 5. So this should be a distance of 8, right? This is 3, this is 5. So this should be a distance of 8. Let's see if our formula works out. So first, let's get the x difference. So it's going to be absolute value of -3 minus 5, which is 8. And the y difference is going to be the absolute value of 5 minus 2, which is going to be 3. And that is correct. And the y we need to go 3, and the x we need to go 8. Okay. Now our diagonal is going to be the minimum of these, so it's going to be 3. And finally, our total distance should be diagonal plus x. Or sorry, no, it's going to be x plus y minus diagonal. So notice, by the way, we can actually simplify this further. So if the diagonal is the minimum of these, we can actually just do x plus y minus the minimum of these two, and that would also solve it. So we can literally just say x distance plus y difference distance minus the minimum of x and y. Right? And let's see what happens here if we do that instead. So our x distance is 8, our y is 3, and the minimum is 3. And then we will get 8. Yeah. And that is correct. We're moving 8. So we can actually simplify this even further. So x plus y minus min x and y, if you think about it, the min x and y is going to be the smaller one. So if we do this, this is basically the same thing as just getting the max of x and y, if you think about it, right? Because the minimum of x and y is going to be this, and then we do x plus y, and if we subtract the minimum, so like let's say x is 5 and y is 8, what's going to happen here is we're going to do 5 plus 8 minus the minimum. So we're always going to subtract the minimum, and then we'll just be left over with the maximum. So the actual distance is just get the two distances and then just take the maximum, and that's actually the path length. So that's the full simplification. We got rid of these diagonals, and this should work for all these. This would also work for this one, just to double check. So here, our distance in the x direction is 3, and our distance in the y direction is 7. So our max of x and y is going to be 7, and that is indeed our shortest path. So hopefully that makes sense. Now that you know you want to always go diagonal and then figure out what the rest of the way is, that is going to be how you do it. And now we can just code this up. So essentially what we need to do is, from every point to go to the next point, we will just loop from the starting point to the second to last point, and we'll just compare that point to the point after it to figure out how long it takes to go from point A to point B. So we can say for I in range length points -1. We're going to get the starting point and the end point, so we can call this like x1, y1 equals points I, and then x2, y2 will be points I plus 1, the one we need to go to. We also need to have a result. Let's have a result. So what we can have here is now we can simply say result plus equals. Remember, we just want the maximum of the two differences, right? So the maximum of the two differences, which is just going to be absolute value of y2 minus y1 and absolute value of x2 minus x1. And that should basically be it. So we simplified our diagonals to just get the maximum difference, and the result, the path length will just be that. Then we just return result. And let's take a look. Looks like we're good. And there we go. And as usual for these solutions, they're kind of all over the place. This is like pretty good. So hopefully this makes sense with the explanation. If you want to use a diagonal, you can definitely use a diagonal, but hopefully with the simplification, you saw that we don't really need it because a bunch of stuff cancels out. So yeah, let's look for the time. The time is just going to be O of n. We're just passing through the point and comparing every two. And the space is O of 1. So hopefully this was helpful. And if it was, please like the video and subscribe to the channel. And I'll see you in the next one. Thanks for watching.